All right, good evening, everyone, and welcome to tonight's webinar on the interplay between vaccination, estrous cycle regulation, pregnancy success, and immune function in cattle. My name is Dr. Lacey Fowler, and I'm a beef technical consultant with Elanco, and I'm thrilled to be your host tonight. Before we get started with tonight's presentation, I wanted to take a brief moment just to refresh everyone on our Elanco Canada ruminant team that supports our customers across the country. Hopefully everyone is familiar with their particular sales rep, but I wanted to give some acknowledgement to the broader Elanco team. In British Columbia, we have Katie McCormick. In Alberta, we have Jackie Burris. Katie covers Alberta as well. On the dairy side and poultry side, Ruth Warwick, Goche Hinef, Tate Young, and in Saskatchewan, we have Aaron Steen, and in Manitoba, we have Murray Easton. In Ontario, we have currently have a vacant role, but an announcement will be coming shortly on that recruitment. And we also have Louise Smith, and in Quebec and the Maritimes, we have Daniel Fournier. And also kind of new to the Elanco team is our new Western sales manager, Chance Butterfield, and our Eastern sales manager, Sarah Andrews. And we have a sales director, Diana Kierstead, who is not new to Elanco, but new to the sales. So we welcome them all to the team. And this is our great group of people. As well as our sales staff, we have the technical consulting team. We have Dr. Jerome Carrier, myself, and Dr. Cameron Olson. So this is our Elanco Canada ruminant team. So hopefully those names are familiar to you. With that, we will proceed with starting the webinar. I'm going to go through a few housekeeping things just to get everybody familiar with how things are going to roll with the webinar tonight. So you can submit your questions through the Q&A function by clicking on the Q&A box and entering them there. We will address as many questions as possible during the question and answer period at the end of this webinar. And any questions that we do not get to, we can follow up with an email answer to the person who posed the question after. Those answers will just go to the person who posed it. If you do happen to experience any technical difficulties tonight, please use the chat function. So either the Q&A or the attendee chat, we can monitor, and our support team will do their best to assist you. However, with this platform, most technical difficulties can be managed just by refreshing your browser. And if possible, this webinar platform does perform best in Google Chrome, if you could use that. The webinar will be recorded for those who can't make the live session. If you attend the live webinar for longer than 45 minutes, then you will receive your CE certificate automatically after the webinar. If you've watched the recording and you still would like to receive the CE certificate, you can reach out to myself or your Elanco sales rep, and we can provide that with you with that. As far as the size of the slides, if you guys have played around with your attendee platform, you'll notice you can resize the size of the slides and minimize the Q&A function. If you happen to minimize it, you can bring it back by clicking the Q&A box at the top of your browser. Also, with that, I think that's kind of the end of our housekeeping. So we'll proceed with the webinar. So at Elanco, we're committed to advancing animal health and supporting the beef industry with science-backed solutions and knowledge. And today's topic is incredibly relevant to reproductive efficiency and is critical for your producer's success. To cover this topic, it is my distinct pleasure to introduce our esteemed speaker, Dr. George Perry. Dr. Perry is currently a research professor at the Beef Cattle Reproductive and a beef cattle reproductive physiologist at Texas A&M AgriLife Research and Extension Center. Prior to this role, he spent 17 years as a faculty member at the Beef Reproduction and a beef reproduction extension specialist in the Animal Science Department at South Dakota State University. He is renowned for his extensive research and expertise in bovine reproductive physiology, particularly the impact of various factors, including vaccination, on reproductive outcomes. His work provides valuable insights into optimizing breeding programs and improving herd fertility. We are incredibly fortunate to have him share his knowledge with us tonight. So with that, Dr. Perry, thank you for joining us, and the floor is yours.
Thank you very much, Dr. Fowler. I really do appreciate the opportunity to get to share some of what we've done over the past several years. And what I want to do this evening is kind of step you through what we've done and our thought process to try to line up all the things of our current knowledge and how we've gotten there. And so, as was mentioned, my training is actually in reproductive physiology. And so a lot of times when I get called for questions, what goes through my mind is really this, the equation of reproduction. There's 4 big areas that can impact reproduction. Animals detected in estrus and inseminated, inseminator efficiency, and fertility level of the herd, and fertility level of the semen. If we take each one of those as a percentage and multiply across, we can see when you do everything very well, 90 to 95%, we end up with a 73% conception rate on a single service. Now, what happens when one thing goes wrong? Let's take fertility level of the herd, which is where vaccinations would come in. If we drop that to 70%, we can see we have an almost 20% drop in single service conception rates. And so where we started with all of this is really looking at reproductive diseases. The majority of the cow herd we vaccinate for trying to control reproductive diseases. And so when we do that, people think of these and they think about the impacts they may have really in fetal infections and pregnancy loss. What is often overlooked is the ovarian dysfunction and estrous cycle dysfunction. This is a lot harder to measure because if we lose a pregnancy, if we lose a fetus, we lost an offspring for that year. If we disrupt the estrous cycle, what is our economic loss? And do people really realize it? And so when we started in this area, I kind of got asked the question of, can I vaccinate my heifers at the start of the breeding season? You're telling me to go through and synchronize them. They're going through the chute anyways. And so as we start digging through the literature, I'm going to focus on IBR, and that'll come up why a little bit later. But when we look back in the 1980s, we can see in naïve heifers, a live IBR injected into 8 heifers the day after estrus. 7 of them had necrosis of the ovary. A modified live vaccine given, CL and ovarian necrosis. Modified live vaccine again, 18 heifers, 4 days after the second prostaglandin. Inflammation in 14 of the 18 heifers. Vaccine again, control, 19 heifers, 2 days after prostaglandin. Vaccinated heifers, 3 out of 10 is all that calved. And so as we go through these and look, we can see getting close to the breeding season, we see infertility, we see embryonic death, we see necrosis. Now, all of these were given in naïve animals. The dogma when we started this area of research was that the follicle that was present at vaccination, I think I can draw here, the ovary or the follicle that was present, we can see right up here, caused that infertility. That the vaccine, we know both IBR and BVD, for some reason, like the dominant follicle. That follicle that was present would get disrupted. That was where we were seeing necrosis in the ovary, but it would be gone. So with current synchronization protocols, this follicle that is present when we start a synchronization protocol, I don't worry about. I'm not worried about its luteal function, because if we put a seeder in place, we put an artificial CL in. So the thought going into it was, when we get out to the point after the synchronization protocol, if all of our effect was on that one follicle, there shouldn't be an issue. And so that was really the question we were asking. And so we designed a study where we came in and we vaccinated at the start, right when the seeder went in. They either got 2 doses of a killed vaccine, which was Virus Shield, 1 dose of Virus Shield, a modified live, which was Bova Shield, or they got saline. When we look at the percent of animals that had an abnormal cycle, we can see that modified live, almost 40% of animals had an abnormal cycle. We did have a few in the killed vaccine group, and we'll talk about that as we go through the study, with no abnormal cycles in the control. And so as we think about it, what is an abnormal cycle? If we look, the green here is our control animals, and we should see that nice rise in progesterone that is maintained all the way out for a full cycle before it starts regressing. What we can see, if you look especially at the red dotted lines, which was the modified live, most of those CLs regressed prior to the time of maternal recognition of pregnancy. So it doesn't really matter whether fertilization occurred, those embryos would die because the corpus luteum would regress. And so thinking about that, our pregnancy rates in that modified live group was only about 30%. We compare that to 70 to 80% in our other treatments. And so even though we did have some abnormal cycles, it statistically did not affect the conception rates in the killed vaccine group. In this study, we were actually monitoring them. We were taking blood samples every other day. We know when they returned to estrus. We had bulls out with them. And what was surprising is in the modified live group, our second service, so when they returned to heat, only about 40% of animals conceived to that second service, where we can see very high rates in our killed vaccines. So as we think about this study, it really changed what the dogma was thinking. That first red circle, that follicle that was present at time of vaccination, the thought was it was the only one that would be affected. What we learned was it wasn't just that, it was also this next follicular wave. The modified live, we had a 30% conception rate after those animals were in estrus. But what was surprising is it was only 40% out here, and we were somewhere day 47 to 52, that our conception rates were only about 40%. And so not only is a modified live vaccine, the viral side of it impacting the follicle that is there at time of vaccination, but it is also impacting them through the next cycles. And so then the question becomes why? Well, as we look in the literature, we know that first follicle turns into that CL and we get necrosis. We get damage of the corpus luteum. We get invasion of mononuclear cells. And so we don't have a normal functioning CL. We can see all the lymphocytes coming into the CL. We can see the damage that is occurring. But what's interesting is in a study that looked at trying to find the virus, they vaccinated animals, they collected ovaries 10 days post-vaccination. They could find remnants of it, but when they actually were looking for the virus, there was only one animal they found the virus in the ovary. And so we really question, is this a direct effect of the virus or what the vaccine is doing to the animal? Now, all of these studies up until this point have been in naive animals. And so when we think about naive animals, we think about the time of follicular growth from antrum formation to ovulation being about 42 days. I'm not aware of any data that would disagree. We want to stay away from modified live vaccines at the start of the breeding season if the animals have never been vaccinated. Now, the reason I point this out is, how do we know the vaccine? If these are purchased heifers, a lot of times we don't know what the background is. If they're animals that have been raised or that y'all have been involved with their rearing, we know, y'all know what you have given them. And it's important what they've been treated with before. But the question that really came up a lot afterwards was, okay, everything we had worked with was in naive heifers, but what about the cow herd? And there were a couple of studies done in the 90s that really looked at the timing of vaccination. So Dr. Stormshack did this study. There was almost 300 heifers. They gave a modified live either 30 or 9 days prior to the start of the breeding season. If we look at estrus expression, AI pregnancy rates, breeding season pregnancy rates, there's no differences. The next study, done in 2007, 800 heifers. Third dose was either 40 or 3 days prior to breeding. And we can see same thing, conception rates, either way you want to look at it, 45-day first service, second service, or days to conception. There's no differences between those treatments. But what is often overlooked, and even when I was in graduate school and we were talking about things, both of those studies compared timing, either 3 and 40 days or 9 and 30 days. And that was all built off of the thought that a vaccination would impact the follicle that was there, but not have longer duration effects. The other thing that was always referred to is this study that looked at giving modified live to animals that had previously been vaccinated. And so what they did was they took animals, they actually had 2 rounds of a killed vaccine, and then for their third treatment, they got a modified live, and they saw no necrosis in the ovary. All the animals cycled, they collected ovaries, and there was no necrotic tissue. But when we go through and look at it, we can see there's animals here that showed estrus, had a large CL, and when we look at the concentrations of progesterone for what should be a mid-luteal phase corpus luteum, they're below what we consider the threshold for progesterone concentrations. So when we look at this, it looks like, even though we don't see necrotic tissue, something is still disrupting luteal formation or the function of the corpus luteum. More recently, there's been a couple of studies that really hint to pregnancy rates. And so we can see this study here, modified live versus an inactivated vaccine, 20% difference given 40 and 10 days pre-breeding, 15% difference at 61 and 31 days pre-breeding. Now, the catch to this study was statistically there's no difference between the treatments, but there's only 10 or 20 head in each treatment. A follow-up study compared modified live to saline. Again, a 20% difference, but again, 60 in the modified live, 15 in the saline was not statistically different. And so while I was still at South Dakota, we decided to do a study, and Russ Daly was our extension vet. We worked together a lot on this study. We were there, let's answer the question. Let's figure out with enough statistical power what exactly is going on in a previously vaccinated herd. We did this study. All of the herds in this study were university herds, either in North or South Dakota. We had vaccination history on every animal from the day they were born. They had all been given modified lives from birth on. We had cows in here that were up to 15 years old. We had 1,436 cows and heifers, 9 herds over 2 years. Blocked by age and previous calving date within each herd. We knew all of the previous vaccinations. We did have some animals that were sold for reasons not related to the study before calving data could be collected. Bad eyes, bad udders, things like that. So we ran 3 treatments. We had a modified live combination vaccine, which was Bovishield, the killed combination vaccine with Virus Shield, and we ran saline. Every animal went through the chute every time. They were either given the vaccine or saline at 30 days, 60 days pre-breeding. We went totally by label. So since none of these animals has had the killed vaccine before, they were vaccinated at 60 and 30 days pre-breeding. The modified live group would have gotten saline at 60 days and the vaccine at 30 days, and the saline group got saline both time points. They were all set up and synchronized the exact same way. They were all in a pasture together. They were all treated at the same timing. They were all AI'd to the same bull by the same individuals. So the first thing we wanted to look at was, is everything healthy in these herds? And so as we look at days postpartum, we can see as days postpartum increased, AI conception rates increased, which you would expect. As cows get further postpartum, conception rates are going to get better. 56-day pregnancy rates, no real differences. Breeding season pregnancy rates, no real differences. I get asked sometimes, why a 56-day pregnancy rate? Well, if we come in and we ultrasound a herd at 56 days, it allows us to look at not only the AI conceptions, but the cleanup for the first round of natural service. And it will allow us to see what those 2 conception rates are versus just later on in the breeding season. So let's look at our treatments. We can see our modified live actually had the lowest AI conception rate, and it was significantly lower at a p-value of 0.055 compared to the killed vaccine. Even at the 56th day, the modified live was lower compared to saline and the killed vaccine. Breeding season, it was lower still. Now, when we get out here to the 56th day in the breeding season, statistically it's lower, but those are very small differences. With the number of animals we have, we are able to pick them up. But we're talking about a 8 to 10% difference here at AI, and our saline group was intermediate. So after that, we kept getting questions of what gives better protection. Is it a modified live or a killed vaccine? And how do we know what a better protection is? And so the group at Auburn published a study around this time point where they had come in and they had taken heifers at weaning and they had vaccinated group A and B with a modified live. Group C got saline, and this was done at day 0 and day 183, so at the beginning of their first breeding season. They were preg checked. A year later, from when they started the study, they either got a modified live, group B got switched to a killed vaccine, group C got saline. So you have group C getting saline all the way through. They calved, their next breeding season, we can see they were exposed to BVD PIs. They were vaccinated on yearly intervals, and so they were vaccinated here again. Then they were given IBR. And then they monitored for abortion and calving. So what did they actually see? There's two different ways this is presented here. So if we look, this top group is BVD found in the fetuses and calves. So if we look group A, which was the modified live all the way through, they had 3 animals abort. One of them that aborted was positive for BVD, and 1 calf that was born was positive for BVD. Group B, which had 2 modified lives and then a killed vaccine, had 1 animal abort. Nobody was positive for BVD. Group C, which was saline all the way through, had 11 of their 15 animals abort. 14 of the 15 were BVD PI positive. IBR, same numbers aborted in all the groups. 2 animals, 2 of the aborted, were positive in the modified live group, none in the killed vaccine group, and 8 of the 15 were positive in the saline group. So when we combined BVD and IBR, we can see 4 out of 23, so 17% either were aborted or infected in the modified live, 1 aborted in the killed, and all 15 either aborted or were infected in the saline group. So if you're a visual person like me, this is more of the way to look at it. In preventing abortions, so this doesn't count into the infected animals, but we can see you're 10% or less aborting in the vaccinated group, and you're between 75, 80% aborting in the control group. So we decided to come back and do a follow-up study because there were people who said, you know, that first study you used 1 vaccine, you compared it, and the p-value was 0.055. So we were 94.5% confident that it was due to our treatments. So we repeated the study, but this time we decided to do it a little bit different. Instead of going exactly by the label, we had 10 herds, we had 1,565 animals, again blocked by age and calving date, 2 treatments. They either got modified live or they got a killed vaccine. And we measured pregnancy success. So we removed the saline treatment, and all of these were done on cooperator herds. So instead of university herds, these were done on cooperator herds across South Dakota. So here it is lined out. The other difference is they only got 1 vaccination. So instead of everybody coming through the chute twice, all of these herds had previously been on a modified live vaccine protocol. We came in with 1 dose of a killed vaccine somewhere between 89 and 27 days prior to the start of the breeding season. They were all synchronized the same way, AI'd the same way, just like before. And so what did we see? Again, about an 8 to 10% difference between the modified live and the inactivated vaccine in our AI conception rates. No difference in our breeding season conception rates. And so even when we were out further prior to the start of the breeding season, we can see that we still had a decrease in conception rates. And so with those at this time point, when I would get asked, what do we know? And it was kind of at this time point, we had 19 herds, about 3,000 animals, 2 different killed vaccines. When we vaccinated with a modified live vaccine prior to the start of the breeding season, everywhere from 27 to 89 days, we ended up with decreased AI conception rates. I could not explain what the mechanism was, why it was impacting conception rates, but we knew that there was an effect there. With those numbers of animals, with those numbers of different herds, I was confident something was impacting things. And so where we've really gone to after that, because running around trying to breed large numbers of animals and get the known conception rates all the way through is very difficult, we've been trying to figure out the mechanism that is impacting things. And so we know that there's several factors. We can get inflammation, cellular degeneration, plasma cell invasion, oocyte infections. All of those really lead us to, is something impacting the corpus luteum? And so one of my graduate students, Caitlin Epperson, who did both her master's and her PhD in my program, really worked in this area, trying to figure out what was going on. And so one of our early studies, we actually followed through vaccinated animals at times day 0. So in all of these studies, what you'll see is we synchronize the animals, we vaccinate them on day 0. And that is a consistency because then we know that is the start of the estrous cycle, and we can actually track everything we're measuring throughout. So they were all vaccinated on day 0. On day 15, and we did uterine flushes and uterine biopsies. Day 17, we did follicle aspirations and granulosa cell collections. And then on day 29 and 30, we did the same thing on a different group of animals. What's interesting is virus isolation were negative. Nothing in the uterine fluid, nothing in the follicular fluid. RT-PCR was negative in granulosa cells and in the endometrium. And so in none of these cases could we actually find the virus in the ovary or in the reproductive tract, which is different than what could be said in naive animals. But what was interesting is we did still have a group of animals in the modified live group that had subluteal concentrations of progesterone. And so we were still impacting the corpus luteum, but we did not have the virus present. And so we had a 10% drop, or 10% of the animals had decreased progesterone concentrations. If we looked at titers, it wasn't the fact that something had a increased immune response. We were not getting increased titer rates. If we look at changes in titers over time, no real difference. Both BVD and IBR. And so even though we thought we were going to come in and find the virus impacting cellular function, we never did find the virus in any of those. But we did see that decrease in progesterone. And so Caitlin's, another one of her studies was actually coming in and saying, okay, what are we actually doing to the corpus luteum? And so we synchronized animals. Again, we vaccinated them on day 0. On day 10 to 13 of the estrous cycle, so what should be mid-luteal phase, we overectomized 13 vaccinated animals and 10 controls. All the animals that were not vaccinated, we can see the modified live, 24% of them had an abnormal cycle. In the killed group, none of them had an abnormal cycle. And if we look at total progesterone concentrations, you would expect this. The gray bar here is lower, saying out of all of the animals treated, the modified live animals had decreased progesterone. What's interesting is if we remove the animals that had an abnormal cycle, so we only count the animals that had a normal cycle length, progesterone concentrations were still decreased in the group that was given modified live compared to the killed and activated vaccine. And when we look at that, we can see that 24% abnormal cycles, where did it come from? 3% delayed rise in progesterone, but 21%, actually the corpus luteum regressed prior to maternal recognition of pregnancy. And so what you can see here is all of these in which that progesterone is dropping before maternal recognition of pregnancy would occur. And this graph kind of shows it more. This is looking at the animals that had normal cycles. We can see the killed group in the solid line. That is their every other day progesterone profile versus the dashed line. We can see by the time we get out to day 4 to 6 post-vaccination or of the estrus cycle, we should be hitting a mature corpus luteum, and we can see progesterone concentrations are decreased. So what actually caused this? The goal of this study was really to collect the corpus luteum. And so we collected the CLs. Here we can see a control animal, and I never know how this shows up on webinars. Hopefully you can see things. If I can draw here, there's a large luteal cell. Here's a large luteal cell. We can see nice, healthy, large luteal cells scattered throughout this control corpus luteum. It looks very healthy. Now, if we compare that, here's a CL from the group that got the killed vaccine. You can see it looks very different. But what we still can see is nice, healthy, large luteal cells. All of these big cells look healthy, are functioning, and they're there. What we see is actually an invasion of immune cells coming into the corpus luteum. Now, how does that compare to the modified live group? If we look at this or this, these are supposed to be our large luteal cells. There, or over here, you can see them really frothy. And so if we look at those, we can see the vaccine is not impacting the large luteal cells. It is impacting the CL, but not the large luteal cells, which produce the majority of the progesterone. When we get to the modified live vaccine, we can see we are clearly impacting those large luteal cells to the point that they're not healthy. So when we looked at it, total number of cells, the control literally had the fewest number of cells per section of the CL because of the invasion of immune cells that were coming in. But when we look at percent large luteal cells, the control was more than double of what our modified live group was. Actually, it's about triple of what our modified live is for percent of large luteal cells. And we can tell the health difference in those large luteal cells. So we wanted to look to see what cells were dying. And so the pink are cells that are dying. And what was interesting is when we had an animal have a short cycle and a new CL was forming, we actually saw the greatest level of apoptosis in those new CLs that were forming. And so we're disrupting not only that CL that forms at vaccination or following vaccination, we're impacting the integrity of the CL that forms next. And so I'm going to go through some of these slides a little quick because I don't know everybody's background on cytokines and everything. We started looking into what other factors could be impacting luteal function. And we know cytokines can play a role. And what these two graphs show are just some of them that stood out to us. But there was no consistency. If they would have all been elevated or lower with the abnormal cycles, that would have been great. But it wasn't consistent like that. So Haley, who's a master's student with me right now, we just finished a meta-analysis that we took 4 different studies. We included all of the cytokine analysis, and we really saw 3 cytokines jump out that were different. And so what we did was compared animals that had a normal cycle versus an abnormal cycle. And if you look interferon gamma, we can see this huge rise on day 2 and those that have abnormal cycles that carried on out further compared to the group that had normal cycles. Interleukin 1 beta, we can see same thing, but it's a delayed rise. It peaked at about day 4. And we can see really no rise in the group with normal cycles. And interleukin 4, it wasn't a treatment by day interaction. The abnormal cycles were elevated over the entire period that we analyzed. And so those cytokines really do seem to be impacting corpus luteum function and are standing out as different in these groups that are having abnormal estrous cycles. Now, the other one that's kind of interesting that we have picked up differences in is VGF. VGF being playing a role in getting blood to an area. We really think that its elevation, and if we look at these big changes that are occurring in the timing, we actually think it's the body trying to salvage or rescue that corpus luteum and the disruptions that may be occurring from the other cytokines. And so we're still investigating that one more, but it's actually interesting that VGF is actually coming up in these animals that are having abnormal cycles at different days. And so we really wanted to then start breaking apart the vaccines and see what role things were impacting. And so a former student of mine, Sarah, when her master's, we were actually able, we gave animals either a control, so saline, a BVD only vaccine, or a BVD and IBR. When we gave just BVD and IBR, 40% of our animals had an abnormal estrous cycle. When we gave BVD alone, none of them did. And so what does this mean? It means that the cytokines that we're upregulating in response to some of these vaccines are actually having a role in the formation and the function of that corpus luteum. And so a question I get asked frequently is, from everything we've done, when should we be administering pre-breeding vaccines? And on replacement heifers, I really think we need to start them at weaning. I think we need to be thinking about our breeding protocols all the way back at the prior to the breeding season, all the way at the point of we select this animal to be our replacement heifer. But in both cows and heifers, I think it needs to be at least 45 days. And the reason I say at least 45 days, I'll show you a meta-analysis that Haley just finished that we've taken things out further. But 45 days is 2 estrous cycles. And if we look at the follicle growth, we need to be out at least 2 estrous cycles before the breeding season. And of course, if they're naive animals, we need to really avoid modified lives prior to breeding season if they're naive. But when I go back to these 2 studies, so this is Dr. Stormshak's at 30 and 9 days. Here's Bolton's at 40 and 3. No differences. When I take our data with working with producers, so the second study, and I break it apart from 27 to 30, 31 to 37, 46 to 49, or 46 to 89, so greater than 2 estrous cycles, we can see modified live was still lower than the killed. But in all of these, both in the modified live and the killed vaccine, we saw a significant increase in conception rates when animals were further postpartum, or further, not postpartum, but further from vaccination to the start of the breeding season. It gave the body a chance to recover. And when we look specifically at the ovary, from antrum formation to ovulation is about 42 days. It gave us a chance because we know these viruses like follicular fluid, they like the follicle, to get everything that had an antrum off of the ovary, and younger follicles being the ones that are ovulating. Now, Haley just finished a meta-analysis, and from the meta-analysis, it would actually say maybe 60 days, even more. And we can see here the difference between modified live and killed at different time points all the way out. This 90 days goes from 90 all the way up to like 270 days. There's just herds we worked with were kind of scattered out after that. But we have really good power in all of these younger, and we can see differences all the way up to 60 days pre-breeding where modified live was decreased. And so to wrap things up a little bit, modified live vaccines have the potential to adversely affect reproduction. We know that in all the situations we've put it in, we have seen disruption of luteal function. We've seen decreased conception rates when we give it prior to the start of the breeding season. This occurs even in well-vaccinated herds. I tried breaking apart the data in both of those large studies into age groups, and it didn't matter what age group I picked out or how I broke it apart into age groups. Heifers, 3-year-olds, 5-year-olds, 7+-year-olds, we looked at it every way possible. It impacted every age group. So I don't have a good explanation on why some animals have this high level of response, have this big cytokine storm that occurs post-vaccination with a modified live compared to other animals. But it is happening in those mature cows and those 10 and 11-year-old cows that were at the research centers that had had modified lives every year. So they had had at least 13 doses of a modified live prior to the studies we had them on. They had a adverse event the same as the younger animals that had not had as much modified live. Now, there are differences between herds. We can pick up some herds, and I can't explain why, but some herds, I always say on average it's 8 to 10%, but some herds it was much greater. I think proper heifer preconditioning, we need to start our immunity in heifers at weaning. We need to get them set up correctly so they're ready to go into the breeding season, and we're not trying to rush and get them vaccinated at the start of the breeding season, which is where a lot of this research began, was producers asking, I'm buying my heifers, I get them right before the breeding season because I don't want to have to care for them. How do I start treating them? that is a bad time to come in and want to get them onto your vaccination program. We know modified lives are better at cell-mediated immunity, where killed vaccines are better at antibody-mediated immunity. So we really need to get these heifers set up correctly. Our data would say that annual killed boosters give very good protection and are very good at not disrupting the breeding season if you're giving them pre-breeding. I always put in, we need to really visit with the vet prior to any changes, because I've been called out to herds that the 8 to 10% decrease in conception rates from a modified live are minimal compared to some of the risky situations that animals are exposed to. Animals where replacement heifers are in pens right next to sale barn cattle that are coming in and getting fed at the same time in yards. Animals where things get commingled. So there are risky situations that we might need that higher level of protection. And so every case needs to be evaluated individually on what is the best management program for their situation to keep the risk down of PIs and everything else, abortions. We need to control all of that. And so with that, I want to thank the second column here is the grad students. They're the ones that really do all the work, along with the research crews, the undergrads and stuff. And then, of course, everybody who has given us funding to do all of this research has been tremendous. And so with that, I think there is still time for a few questions, and I'll be happy to answer any questions.
Excellent. Thank you, Dr. Perry. So that was some great information, and I really appreciate your commitment to doing the research and collecting the data on this. There's a lot of factors that go into these things, and your team has done a great job at really diving into the what and the why. So if you haven't already submitted your questions, please go ahead in the Q&A chat. The questions are anonymous, and we will kind of read a few of them here, and I do have one. So one of the questions that we received was, how can we differentiate whether we're seeing the effect of the interval between pre-breeding vaccination and breeding, or whether we're seeing the effect of a longer interval between calving and breeding? Do you have any comments on that?
Yes. So I get comments all the time from producers and even some veterinarians on, well, we never see this effect. It's hard to evaluate in small situations. That's where, like in our research studies, when we design them, everybody is blocked by days postpartum. So we can, in research, account for days postpartum and vaccine treatment in the experimental model and know how much each is impacting things. In a producer's herd where you're looking at everybody's vaccinated today, I have differences in postpartum interval. Am I really seeing a negative effect of modified live? You're not running a control group or a comparison. It's a lot harder to tell. And so if you're giving a modified live and cows are both short postpartum, I think that confounds in there because those short postpartum cows aren't going to have as good a cyclicity. We do know short postpartum cows will short cycle on their own to the reprogramming of the uterus. But we do know, like in our research studies with the large numbers we have, we were able to separate those two things statistically.
And another question that we received here is, would a vaccination program in late pregnancy still offer the repro protection that a pre-breeding program would?
So the short answer is yes. All of the companies, everybody, and Dr. Fowler, please join in on what Elanco knows, or y'all's products more specifically, have done duration of immunity studies, and almost all of the vaccines I know that are commercially available have gone out to somewhere between 11 and 12 months and shown duration of immunity. I do know of a few products, the papers were never published that went longer. And so, yes, if you come into late breeding or late pregnancy, so at time of preg check, or that is kind of the alternative. I know lots of herds we work with that give a killed vaccine at time of preg check. They get two benefits that way. They will actually increase antibody production and colostrum, but then they will also still have the protection going into the breeding season. And so, speaking of Virus Shield, I'll let you talk about some of the data. I know y'all have done it looking at duration of immunity, but I think y'all are comfortable at that duration pre-breeding, it's still having good protection.
Yeah, I think lots of our studies have gone out to that 1 year mark, or at least 11 months. The IBR study was done to 11 months, and that's one of them. And then even our Vibrio study did out to a year, and providing protection at breeding time. So, and that was a really strong challenge study looking at both vaginal inoculation and positive bulls that they tested these heifers with, and they showed that, you know, even out at 360 days or 365 days post vaccination, they had immunity for that. So yeah, I think that's really interesting. And, you know, we only have so many times that we can put these animals through the chute to vaccinate them on the beef operation. So, you know, picking which one of those 2 times is really important. I think with that, we're kind of wrapping up. I'll see if there's any other questions that come in. Yeah, so one question that we had here is, given the work that you've done on the female side and the looking at cytokines, is anyone doing research on the effect that vaccinations pre-breeding have on bulls? Do you have any comments on that?
Yes. So there was a study that was just published this past year from Texas Tech that had, I think it was 5 or 6 bulls per treatment. They looked at basically, would a bull pass a breeding soundness exam? They saw no difference there. We are waiting. I have a group of bulls at the research center that I'm waiting to reach sexual maturity. Once they reach sexual maturity, we are going to vaccinate them with either a modified live or killed vaccine. But what we have been able to show, we did a preliminary study last year that we had some bulls in a treatment, and we can measure the cytokine profiles and all of that even in the ejaculate. And we know cytokines actually play a role in spermatogenesis. And when I look at the study from Texas Tech, there was 1 bull out of their 5 that you do see a big drop in. And so when we get in ours, and I actually have a flow cytometer in the lab, we're going to do a lot more in-depth analysis. Bulls are a lot harder to evaluate, but that is one of the things we're starting to look into. And so hopefully over the next year, we're able to collect the data on mature bulls. And the hardest part of that has been, I haven't found a producer that wants me to come in and try on his bulls before they go out to a breeding season. So I've had to develop a group of bulls that are going to be dedicated to this study.
Okay, excellent. Yeah, interesting. It'll be interesting to see the results of that work. There's one question here, just if you had any comments on extrapolating the results of your research to pre-breeding strategy used in dairy cows and to dairy animals, because fertility in dairy cows is definitely you know, a hot topic. If you could comment on extrapolating that to them.
So on dairies, there's some similar work that has been done that showed getting out greater than 45 days. I think the one study I'm aware of, they were out at is either 47 or 49 days pre-breeding between vaccination and any breeding, and comparing a killed and a modified live, and they did not see differences between those two. I do think in some dairies, as long as they're running them as a pre-breeding, I know some dairies that don't look at the interval from vaccination to breeding. They're just on a set schedule. I vaccinate everybody this day of the year, and then everybody on this day. And those are a lot harder to extrapolate into because you'll have pregnant cows and open cows that's the day that pen gets vaccinated. Those are a lot harder to evaluate because they are so confounded with everything else going on, from peak lactation to postpartum interval and everything else. The herds that are looking at it as far as before, the data that's out there, at least in dairy heifers, would say that it's very similar to what we're seeing on the beef side.
Excellent. Yeah, that's perfect. Thank you. Well, I think that kind of wraps up the questions we've got, and we're just kind of heading at the end of our time here. So thank you everyone for taking time out of your busy schedules to join us. I think that Dr. Perry presented some very valuable research studies. At the end of the webinar, the attendees will get just a short survey of questions. Please, we really value your feedback, and if there's anything you'd like to see in the future or improve upon, it's great to hear from everyone. With that, I'll thank Dr. Perry again, and thank you everyone for attending. There are resources available that for the attendees to view. So there is PDFs of the slides. So I mentioned that in the attendee chat, but just if you didn't get to see those, there's PDFs of the slides for future reference, as well as some other just documents just covering Virus Shield and just the product outlines. But please feel free to follow up with your Elanco sales reps or myself if you have any further questions. And we'll be sending out a follow-up email with a copy of the recording as well. Please feel free to share that with others that you think would benefit from this content. So once again, thank you everyone for your attendance, and we wish you a wonderful evening.
Thank you all very much.